abstract ideas, symbols, and rules that we cook up in our own minds, is so ridiculously good at explaining how the entire universe works? It's a question that sounds like it's straight out of science fiction, but it's one of the deepest puzzles in science.
You know, the physicist Eugene Wigner put it perfectly. He called it the unreasonable effectiveness of mathematics. And it really is unreasonable when you think about it. Why should the cosmos care about the scribbles in a mathematician's notebook? It's this deep, fascinating mystery that has kept scientists and philosophers up at night for centuries.
So today, we're going to be detectives. We're going to follow the clues piece by piece. We'll look at the incredible powers that make math the ultimate partner for science and see if we can get just a little bit closer to cracking this cosmic case.
Okay, first up, let's dive into how scientists actually use math on a daily basis. You can think of it like a universal toolkit, one that has a few special features that make it unbelievably powerful for understanding pretty much everything.
The first power is just sheer precision. I mean, our everyday language is kind of fuzzy, right? If I say an object falls fast, what does that actually mean? Fast compared to what? But math doesn't do fuzzy. When Galileo went from a vague idea to that exact equation, he created a law of nature that means the exact same thing to you, to me, to anyone, anywhere on Earth. It's unambiguous.
And this precision leads to what is, honestly, science's greatest superpower: prediction. Once you have a mathematical model that works, you can use it to figure out what's going to happen before it actually does. It's what turns science from just describing what's already happened into basically a form of prophecy.
And wow, the track record here is just incredible. You've got James Clerk Maxwell's equations predicting the existence of radio waves more than 20 years before anyone ever found them. Then there's Einstein, whose math said gravity should bend light 4 years before an eclipse proved him right. It's amazing! The math points the way, and reality just seems to follow its instructions. Okay, now for the next superpower: math's uncanny ability to show us hidden connections. So take a look at these 4 things. What do they really have in common? On the surface, not much, right? Ripples on a pond, sound, light, the bizarre world of quantum mechanics. They all seem like totally separate things. But here's the kicker. This one mathematical structure, the wave equation, describes all of them. And that is so much more than just a neat party trick. It's telling us something really profound about the universe itself. It's saying that nature isn't just a random collection of stuff, but that it has this deep underlying unity. It has patterns that repeat over and over again. And math is the language that lets our brains see that beautiful unity.
And what's more, math is just unbelievably efficient. Take the most famous equation of all time, E equals mc squared. That one tiny statement contains a whole universe of meaning about the fundamental relationship between mass and energy. If you wanted to explain all of its implications using plain English, you'd need pages and pages. The math gives it to us in 5 characters. It's the ultimate compression tool.
But here's where it gets really mind-bending. The power of math isn't just about describing the world we can see and touch. No, its real strength is taking us to places our intuition just can't handle. Think about it. Our common sense is fantastic for everyday stuff, like, not walking into walls or catching a ball. But when we get to the extremes, the incredibly small, the unbelievably large, or the ridiculously fast, our intuition just completely falls apart. It gives us zero help in the quantum world, where particles can be in many places at once, or at the cosmic scale, where gravity is literally the fabric of space-time bending. Our brains just weren't built for that.
And in these realms, where our gut feelings actively lead us astray, math becomes our one and only reliable guide. We can't actually picture a quantum superposition, but we can work with the equations that describe it perfectly. We have to learn to trust the logic of the math, even when, especially when, it leads us to conclusions that sound completely absurd. So we've seen the evidence. Math gives us precision, prediction. It unifies different ideas, and it guides us way beyond the limits of our senses. Which brings us right back to that big central mystery. If math is this powerful, where does it actually come from? And this, for me, is the weirdest clue of all. Again and again in history, mathematicians have just been playing around, inventing purely abstract ideas. Things like imaginary numbers or weird new geometries, just for the fun of it, with absolutely no practical use in mind. And then, sometimes decades or even centuries later, physicists working on a totally new problem discover that this weird, obscure bit of math is the perfect language they need. It happens so often, it's spooky.
So this leaves us with two big possibilities, two ways of looking at it. On the one hand, maybe math is something we invented, a powerful, logical language created by our brains that just so happens to be a fantastic tool for describing the universe. Or, and this is the more mind-bending idea, maybe math isn't invented at all. Maybe it's discovered. Maybe it's an objective feature of reality itself, like gravity or the speed of light, and we're just slowly, piece by piece, uncovering its timeless truths.
And that leaves us with this final, powerful question. Galileo famously said that the book of nature is written in the language of mathematics. But the real puzzle for us is this. Did we invent that language so we could learn how to read the book? Or was the book written in that language from the very beginning? It's a question that gets to the very heart of what reality is and what our place in it might be. Thanks for digging into this with me.